Hello all. Welcome to Conf42 Python. I thank you for attending this session, and I would like to go over some of the use cases of Python in deep learning and how it can help us in building a lot of deep learning and data engineering and these kind of transformative apps. And let me first quickly give you a short introduction about myself. I have total experience of 8+ years in machine learning, data engineering, as well as cybersecurity. I graduated from Northeastern University with information systems with specialization in machine learning and data analytics. So in this presentation, we will dive deep into how machine learning and deep learning have enabled transformation, and all these applications, they are built on Python using packages like TensorFlow, PyTorch, and all the other deep learning packages. So let's go through this slide over here, which illustrates about reinforcement learning. So as we know, there are a lot of capabilities in machine learning. These are related to supervised learning, unsupervised learning. So these kind of algorithms are kind of very basic algorithms. They are used widely in industries. But right now, reinforcement learning is making a lot of inroads because of a lot of good algorithms are being developed on basis of that, and these kind of algorithms are shaping the future, and they are enabling a lot of superhuman capabilities. So these kind of reinforcement learning, they have, once they are trained in a very proper way manner with less errors and higher accuracy, this can lead to building superhuman or a deep brain kind of capabilities. Like if you see chat gpt and other llm models, they are generative and they are able to kind of do the thinking and provide us with the answer. So these kind of capabilities have evolved through reinforcement learning. For example, if you see DeepMind, AlphaGo, then recent breakthroughs in theory, these have a lot of reinforcement learning involved, and these are shaping the way for the future, especially in robotics and various other fields. Then we look into the generative models over here. So over here, I have mentioned about generative adversarial network autoencoders. So what is the difference between the two? GANs are mostly generative models, and they are kind of more of generation, image generation, and that kind of thing. And they currently have higher accuracy as compared to VAEs, but VAEs are more powerful probabilistic models which have capabilities of anomaly detection, then threat detection, working on the data set in cybersecurity realm. So in cybersecurity, these kind of VAEs are very powerful and they are utilized. And in future, we might see a lot of trends of utilizing such kind of algorithms. Both of these algorithms are based on neural network based algorithms, and they have evolved, and probably they will make a system more capable, and a lot of applications will be developed in future. Now we see over here the rise of generative models in design and art. So currently machine learning and deep learning technologies are being used in tech as well as healthcare and cybersecurity fields. But in future, we'll see a rise of these kind of models being utilized in architecture, art, and all those industries, because they have the capability to kind of generate, like they have the ability to understand the pattern. So if somebody has certain things in mind, and if you enable such kind of decision making, then these kind of models can generate certain kinds of design, whatever you have in your mind, and if you are able to convey it to the model, and the model will in turn generate the design and art for you. So it will become that kind of a powerful system in future. Now, in AI, AI is very useful in cybersecurity, not because it can do all the basic tasks, but because these generative models, they might be able to do a lot of threat detection, vulnerability assessment, fraud prevention, and such kind of activities. And this is because the algorithms have evolved in such a high way that these kind of threat detection, instead of taking SIM tools, we can use such kind of algorithms to detect threats in the organization. So, for example, let me give you a scenario. If there are a lot of cyber criminals which are using AI-based tools like ChatGPT and various other tools to do phishing attacks, DDoS attacks, and such kind of things. So in threat detection, if we leverage such kind of models, deep learning models, and train them using Python, then this will become it will help us in developing and mitigating such kind of threats. And it will also enable vulnerability assessment, fraud prevention, and such kind of activities, which are not clearly and not that powerful using existing tools. Although I would say, although these kind of existing cybersecurity tools are good enough, but there is 10% chance where such kind of tools might fail. And in such kind of situation, if we take help of AI tools like RNN, recurrent neural network, these kind of AI algorithms can help us to detect certain threats, then predict vulnerabilities, some fraud prevention, that kind of activities. So these tools, instead of relying on such kind of cybersecurity tools, we can leverage AI algorithms which are trained using deep neural networks using Python. And this can enable us such kind of better security posture within the organization. There are many algorithms like neural network. For example, Microsoft as well as Amazon also has certain kinds of threat detection algorithms which they are training and building upon their AI tools to improve the cybersecurity and operations within the organization. So in future, we might see long vulnerability assessment and fraud prevention activities done by AI, and it will have better accuracy score in future. Now we come to graph neural network. So GNNs are also a powerful tool within cybersecurity, which can enable us to identify anomalies, predict threats, do complex kind of transformation, relationship mapping, and maybe it can detect certain kinds of anomalies within the data, vulnerability data, which SIM tools like Splunk, Alien Vault, and such kind of tools cannot detect. So these algorithms, if they are trained and if they are able to provide a good picture about the anomalies and security posture, these algorithms can become very good helping hand in uncovering certain kinds of threats. And what I am explaining over here is not just using these kind of tools, but also integrating them with the existing cybersecurity tools. Organization can have better outcome of detecting DDoS attacks or certain kinds of threat actors and identifying cyber criminals. So it's quite beneficial, and these kind of models should be trained so that security posture and threat detection capabilities can be increased. Now we come to future of AI in cybersecurity. So there are multiple aspects where AI can help. This is right now in threat detection. Obviously, it can help us to provide some immediate inroads, and in future, it can also help us to identify the attackers. If let's say if the attacker is using AI-based tools, these kind of things can be kind of detected by AI tools rather than using the existing cybersecurity tools. And organizations can improve their security reporting, then when there won't be that many requirement of that many folks to look into the basic aspects. So basic security aspects and reporting can be automated by using AI, whereas security engineers and other folks can look into some other advanced aspects. So the work can be distributed and cybersecurity operations can be improved in such a way. And now we come to ethical considerations in AI. So over here, AI can be a good thing in cybersecurity and other operations, but AI, there are a lot of issues like privacy and security issues, then bias and discrimination and all those things, and job displacement kind of issues. So these are some ethical considerations of AI which we need to look into as we try to fine tune and deploy the models in production. We need to look into the compliance aspects as well, compliance and governance related processes, that AI would be able to have any privacy implications or security related implications. So based on what kind of data you are feeding to the AI algorithm, these kind of things needs to be discussed with the compliance and I would say the security and compliance team, and also governance and other teams. All these things needs to be discussed so that the AI algorithms are capable enough and they don't hamper any of our ethical considerations. Now we come to recurrent neural network. So a recurrent neural network, what is a recurrent neural network? This kind of a neural network is a very advanced level neural network which focuses more on kind of detecting threats, finding the anomalies in the data set, then predicting the anomalies and that kind of thing. It behaves very different from convolutional neural network, because convolutional neural network, for example, is used more into autonomous driving and detecting images and classifying images and such kind of thing. Whereas RNN is a neural network which is based on more of detecting anomalies in a data set and finding and improving the security posture within the organization. So those are the use cases of RNN, and RNN is currently very extensively used in such kind of anomaly detection. I would say before implementing RNN algorithm, we should look into some basic algorithms like XGBoost is one of them. Then we have isolation forest, which is also a very good algorithm, which I have trained to look into the cybersecurity data set. We'll go through that in our next few slides. So the RNN architecture, this slide mentions about the architecture of RNN, and it has input layer, hidden layer, then activation function and output layer. So it's like advanced features as compared to neural network, where it has input layer, then hidden layer, which are trained in a different way. Then we have activation function, which is also kind of developed in a different way as compared to traditional neural network. And some of the use cases of RNN are associated to language modeling, generating text, then speech recognition, then we have translation of machines, image recognition, and such kind of things. There are a lot of use cases of RNN currently in cybersecurity, where it can detect threats and then provide details of the threats, vulnerability detection, and that kind of thing. Currently the best algorithm which can be used for time series is the transformer based time GPT. So time GPT is the algorithm, the model which is developed by Nixtla. This company uses heavily transformer based models to predict. It provides a time series analysis and it is very powerful. And the use cases are related to finance, web traffic analysis, Internet of Things, weather forecasting, are related to anomaly detection, finding anomalies in a data set, classifying the anomalies and such kind of thing. So time series is also, time GPT is a very important algorithm, and since it is transformer based, it has evolved quite drastically as compared to traditional neural network. And I would like to, we will be able to see a lot of applications of transformer based algorithms in near future, because right now the trend is going on where a lot of AI applications are being developed on transformer based kind of models like ChatGPT and all those things. All these kind of applications are developed using transformer based models. Even these kind of algorithms which are being used in DeepSeek, these kind of companies are using transformer based models which are trained in a very different way as compared to normal neural network based algorithms. So I believe transformer based models will have a lot of big impacts in next few years. Now we come to this very good use case of Python with Spark integration. So I have done some work on Spark earlier, so I am providing some details about how Spark can help backend and machine learning engineers, because This is a distributed framework for big data processing, and it is very easy to use, and it helps to integrate with REST API and various other databases. Spark currently has a capability to integrate with these backend data stores like Cassandra, then MongoDB, then all the and other faster NoSQL databases. Spark also integrates very quickly with Kafka. So if your distributed system has Kafka and all these tools, then you should also consider Spark integration. In Spark integration, what you need to do is to use PySpark, where you try to write an API, query the API using Spark, PySpark, and then store it into the tables. You can also store it into any kind of databases, and it is very powerful. It works with distributed systems. It can provide you the transformation. You can do transformation using Spark and then dump the data into any kind of a data store. And it is very fast and very scalable enough. The real world applications of Spark are related to big data processing, developing ETL pipelines, performing transformations, then querying and writing into APIs, fetching, ingesting data from APIs, and all those things. And also machine learning capabilities in Spark is also very good, but it is not very much good like the existing deep learning capabilities. And streaming, Spark applications are mainly used for streaming, building streaming applications and taking the data from Kafka or and putting it into any kind of data store after transformation. Now, next we will go into deep dive into the code. So this slide over here provides details about the Python PySpark code. This code is basically to ingest data from REST API. And after we ingest the data from REST API, we are writing it. And this code over here, it will try to take the data from API and put it into a Spark data frame. And Spark data frame is very powerful because it can handle tons of data as compared to, and we can data store after ingesting the data from web API. Now we look into this. This is a vulnerability data set, which I was talking about. Deep learning and machine learning based capabilities are good enough to detect threats. So this data is a vulnerability data with having multiple columns related to vulnerabilities. Then we want to identify these kind of vulnerabilities not by using tool, but by using AI model. So over here, I have developed this AI model where I'm cleaning the vulnerability data. And we have certain criteria over here where we are taking the clean data with complexity. Over here, we are trying to find out high complexity and medium severity and CVSS score of greater than 6. And then I have written this. First of all, I have done perform cleaning over here. And after cleaning the data set, I have performed transformations and looked into certain features which we require, like CVSS score, severity encoded, complexity encoded. And then I have trained the model isolation forest over here. And after I perform model training, I have also and developed the anomalies. So this anomalies of clean data consists of high, all those which have complexity high, severity of medium, and CVSS score of greater than 6. And finally, I am able to, the model is able to provide the anomalies. And this can be obviously automated by using other highly capable models as well. But I have tried using isolation forest. And then I had also tried this kind of anomaly detection using XGBoost, and I'm trying to leverage RNN and other transformer based model to predict certain anomalies in the data set. So in few months, I will be using transformer based models to predict certain anomalies within the data set. Now we come to over here, the convergence of AI and security. So AI and security, these are very different kind of things, but AI can be used in cybersecurity in improving the security functions. So it cannot generally replace all the existing security tools and features, but it can help us to provide more better mitigation, detection, threat detection, fraud detection, and those kind of capabilities. So it is likely to help the team in building more better security posture within the organization. And transforming industries, the impact of AI advancement is kind of helping in building more of autonomous systems, drug discovery, and developing personalized medicine. So these kind of things are the use cases which can be done in future, but right now the capabilities of AI are to improve the cybersecurity as well as some of the tech industry, improvement of the processes within the tech industry. And what are the key takeaways? So in this slide, I have mentioned about the deep learning, since it is having a lot of AI models like reinforcement learning, generative models, and all these things. But it is critical to understand what use cases they can help in. So we have to understand the use case in a better way and then go into specific models which can help. And the basic things are to start with the simpler models and then automate it and improve upon and then look into some advanced modeling capabilities. So in that way, we can automate certain processes in cybersecurity, in data engineering, as well as analytics. And it can also help in building analytic pipelines. So that's it from my side. Hope you like this session and let me know if you would like to have more additional information. Feel free to connect with me on